13.8.2 CFT. It was just calculated, okay, the PCC work. Now the ratio for this, if you remember, it was just in the foundation, okay, and I think it was just 3 inches, okay, so you have to confirm that, no problem. It was, I think, 1:3:6 ratio. If you just calculate, okay, like if what it was just in foundation, maybe like this, okay, so it's just like a slab, okay, we had 13.812 CFT, okay, and this is PCC plain cement concrete. So when we calculate all these things, we actually multiply the breadth with the height or thickness and then with the length. It becomes actually the wet volume. So this volume is now actually wet volume. The ratio, that is 1:3:6, it means the summation of ratio or the sum of ratio should be 10. In order to determine the quantity of cement, let's just calculate cement. Remember the same formula. The ratio of cement, let's say the ratio of cement divided by the sum of ratio, and we multiply this with dry volume. So the cement should be now the ratio of cement, which is actually 1 divided by the sum of ratio, that is 10. Okay, and we will multiply this with dry volume. Now, what's dry volume? Dry volume is actually the wet volume, which is 13.81. Okay, and we will multiply this with 1.54. Now, 1.54, this is, it may be varies depending upon your country and depending on the materials used in the same concrete. I have read many books and this video is different, okay? It can be 1.50, it can be 1.51, okay? It can even be 1.49, okay? So it depends on the properties of the fine aggregate and then coarse aggregate, and even depending on the cement. So why we take 1.54? This is a good question, okay? But before answering that, let's just calculate this value first. So the quantity of cement should be now, okay, if you multiply 13.81 with 1.54, this should be actually 21. And 21 times 1, this is the same thing. And we will divide that by 10. So we can have the quantity of cement, which should be 2.127 CFT. So 2.127 CFT is actually cement. Now divide this by 1.25 to have the quantity of cement in form of bags, okay? So we should have 1.701 bags. Now, why do we need to convert wet volume into dry? This is a good question. Is there anybody who has any idea about this?
No idea.
The question is actually, we're here, okay? We just converted the wet volume into dry by multiplying 1.54, okay? So why do we need to convert wet volume into dry?
ड्राई वॉल्यूम सर ज्यादा होता है जब हम पानी उसमें ऐड करते हैं तो फिर उसका वॉल्यूम कम हो जाता है वो कंप्रेस हो जाता है सर
Exactly. You are clear, okay? So what happens actually, if you see, we have aggregates like maybe crust stone, okay? These are crust stone. And there can be actually maybe sand like this. And here we have cement, very fine, okay? So we have three materials. This one sand, and this one crust stone, or maybe coarse aggregate, if you use technical words. Sand is known by the fine aggregates. Now, what happens actually, if you bring, okay, if you carry the crush, okay, there are spaces, maybe voids, okay, these voids, okay, so these voids are filled with the quantity of sand. And even these voids, or maybe the voids in sand, are filled with the quantity of cement. So this is actually the basic approach. And this is the idea, okay? So what happens is actually, let's say, if we bring 100 CFT crust stone, 100 CFT sand, okay? And even 100 CFT maybe cement, okay? Which is actually not the same thing, right? This can be 50 maybe, this can be 25, or even we can say, let's say if we have 1 CFT, and then we have 2 CFT, and then we have maybe 4 CFT, okay? Okay, let's not consider that. Okay, so we have one CFT, we have two CFT, and then maybe 4 CFT as the crust stone. Okay, so what happens actually, this is very, you can say this is maximum. Okay, the volume is maximum. Okay, we bring it in dry form. Now we know it in advance that after adding water or mixing these three materials, we may have the shortage of 54%. Is that clear? That's why we add in advance. Okay, we add 54% volume in advance. This is the basic concept. So for one CFT, if you add 54%, it means 1 plus 0.54. This becomes 1.54 for one CFT. So this is how we have 1.54. Is that clear? This is how we can just calculate maybe the cement. Okay, where is it? We have 2.127 cement. So this is cement, and now we will just calculate the quantity of sand. Let's say we have sand ratio, it was just 138. So what you have to do is to take the quantity of cement first, that is 2.127, multiply this with the ratio of sand, that is 3. So we should have 6.381 CFT as sand. Now let's calculate the crust stone. We have cement, which is actually 2.127. Now the ratio of crust stone, which is 8. Okay, so we will multiply that with 8. I'm not going to repeat those formulas like the ratio of the material divided by the sum of ratio times the dry quantity of the material. Okay, this is just for kids. So we will use these simple things, okay, times 8. So we must have maybe 17. Okay, we have 136. That's good. We have 136, so we will put 3 over here. You are good. Thank you. We have 6 here, okay? It means that 2.127 times 6, this is actually 12.762 CFT. Thank you. That's good. Okay, so this is called, and this is known by the material analysis of PCC work.